Basically, we are having two types mainly as far as AI is concerned. So one is the
Yes.
generalized AI, which is nothing but the search strategies. All the search strategies comes under the generalized AI. So AI starting up there, initialization up there, you will come across all these terms like breadth first search, depth first search, and all the kinds of search strategies. So ఈ search strategies ఎందుకు అంటే మెయిన్గా వీఆర్ గోయింగ్ టు ట్రైన్ సమ్ ఏజెంట్స్ టు రీచ్ ఎ పర్టికులర్ గోల్. ఏజెంట్ అనేవాడికి ఒక పర్టికులర్ గోల్ స్టేట్ రీచ్ అవ్వాలి. సో అది అల్టిమేట్ ఎయిమ్ ఆఫ్ ఏఐ. సో వాట్ ఎవర్ ఇట్ మైట్ బి వీఆర్ ట్రైంగ్ టు మేక్ ద ఏజెంట్స్ యాజ్ ఇంటెలిజెంట్ ఏజెంట్స్ by giving some sort of
Yeah.
intelligence to that particular agents. They are going to act accordingly. So that is the main thing that happens as far as AI is concerned. So in this, we are having one of the most important aspects that is called as knowledge-based agents. So what are the basic aspects of knowledge-based agents? So before we discuss regarding the knowledge-based agents, you need to know regarding the logic and the importance of logic in AI. సో లాజిక్ అంటే ఏంటో తెలియాలి, లాజికల్ ఇంప్లిమెంటేషన్ ఏఐలో ఎందుకో తెలియాలి. ఈ రెండు ఆస్పెక్ట్స్ మెయిన్గా మనకు తెలియాల్సిన ఆస్పెక్ట్స్. సో లాజిక్ ఈజ్ నథింగ్ బట్ విచ్ ఈస్ గోయింగ్ టు ఓవర్కమ్ ఆర్ డౌట్స్. మనకి ఏమైనా ఒక క్వశ్చన్ డౌట్ ఉంటే ఆ డౌట్ నుండి ఓవర్కమ్ చేసే ఆస్పెక్ట్ నే నాలెడ్జ్ అని అంటాం. సో నాలెడ్జ్ యొక్క ఇంపార్టెన్స్ ఏఐలో ఎందుకు అంటే మెయిన్గా ఆఫ్ అదర్ టెక్నాలజీస్ అండ్ కంపేర్ టు ఏఐ we are going to make some sort of intelligent steps. Suppose ఒక టెస్లా కార్ ఉంది, ఆ కార్ మూవ్ అవుతుంది. మూవ్మెంట్ అయినప్పుడు నీకు ఒక సర్టెన్ డిస్టర్బెన్స్ కనుక జంక్షన్ కనుక అక్కరైతే నెక్స్ట్ స్టెప్ ఏం తీసుకోవాలని ఆటోమేటిక్ గా కార్ కి ఎంబైబ్ అయి ఉండాలి. సో దట్ ఈస్ ద మెయిన్ థింగ్ యాజ్ ఫర్ యాజ్ ఏఐ ఈస్ గోయింగ్ టు డూ దిస్. సో మెయిన్ గా ఒక పర్టికులర్ డైరెక్షన్ లో నువ్వు ట్రావెల్ చేస్తున్నప్పుడు అక్కడ నువ్వు హౌ టు టేక్ ద రైట్ స్టెప్ that should be given by the system. So ఏ కైండ్ ఆఫ్ స్టెప్ కరెక్ట్ స్టెప్, ఏ కైండ్ ఆఫ్ రైట్ స్టెప్ నేను తీసుకోవాలి అనేది పర్టికులర్ గా సిస్టమ్ చెప్పాలి. సో దట్ ఈస్ ద మెయిన్ థింగ్ దట్ హ్యాపన్స్ యాజ్ ఫర్ as AI is concerned. So in this knowledge based agents, we are going to make up the complete set of a sentence. అంటే మనము we are having two aspects. One is knowledge, another one is wisdom. నీకు కొంత నాలెడ్జ్ ఉంటుంది, నాకు కొంత నాలెడ్జ్ ఉంటుంది. బట్ నాలెడ్జ్ ని ఎవరి నాలెడ్జ్ ని వాళ్ళు కంప్లీట్ గా రిప్రజెంట్ చేస్తేనే వాళ్ళు ఎక్కడ ఉన్నారు, ఏ బేసిస్ మీద ఉన్నారు, తర్వాత అప్కమింగ్ ట్రైనింగ్ ఏంటి అనేది ఓవరాల్ గా తెలుస్తుంది. సో నాలెడ్జ్ బేస్డ్ ఏజెంట్స్ ఆర్ ద ఏజెంట్స్ విచ్ ఆర్ గోయింగ్ టు మేక్ ద ఏజెంట్స్ ఇన్ ట్రైన్ ఇన్ ఏ పర్టికులర్ మేనర్ సచ్ దట్ ఇట్ హ్యాస్ ఇట్స్ ఓన్ ఇన్ఫరెన్స్ బేస్డ్ సిస్టమ్స్. అంటే నేను ఒక సార్ట్ ఆఫ్ ప్రెడిక్షన్ లోకి వెళ్తున్నాను. సపోజ్ ఇవాళ వెదర్ ప్రెడిక్షన్ తీసుకో, ఇవాళ ఒకలా ఉంది, రేపు ఒకలా ఉంటుంది, ఎల్లుండి ఒకలా ఉంటుంది. సో ఇది కంప్లీట్ నాలెడ్జ్ అనమాట. ప్రీవియస్ గా నాకు కొంత నాలెడ్జ్ ఉంటుంది. సో హలో హలో
Sir is listening.
ఓకే ఓకే. సో ప్రీవియస్ గా నాకు previously I have some certain way of knowledge with the previous experiences. I have some knowledge and you have some knowledge, and based on that knowledge we are going to predict the upcoming stages or upcoming inferences that occur in this particular agents are concerned. So we are trying to build an inference based system based on the knowledge that we have obtained. So suppose let us just consider the weather conditions as an example. Previous I have temperature of 35 degrees, and the day before yesterday I have around 32 degrees. Today I might have 45 degrees. So this is the inference I am going to draw based on the knowledge that I have in the previous experience, with the previous experience. సో నిన్న టెంపరేచర్ నాకు 32 degrees ఉంది, మొన్న టెంపరేచర్ నాకు 35 degrees ఉంది, ఇవాళ టెంపరేచర్ నాకు 37 degrees రావచ్చు అని ఒక సార్ట్ ఆఫ్ ప్రెడిక్షన్ లోకి వెళ్తున్నాం. సో దిస్ సార్ట్ ఆఫ్ ప్రెడిక్షన్ ఈస్ నథింగ్ బట్ వన్ కైండ్ ఆఫ్ ఎ నాలెడ్జ్ బేస్. I have certain basic gates of knowledge as far as my inferences are concerned. So based on the previous knowledge and the present knowledge, I am going to judge the futuristic knowledge. And based on these knowledges, I am going to predict the upcoming aspects or the upcoming predictions as far as the system is concerned. So overall, the knowledge base is one kind of a knowledge transmission system which is going to generate as far as AI is concerned. సో మన న్యూరాన్ కానీ హ్యూమన్ బ్రెయిన్ కానీ ఎలా ఉంటుందో అలాగా ఒక నాలెడ్జ్ బేస్ ఉంటుంది ఓవరాల్ గా. సో ఈ నాలెడ్జ్ బేస్ ద్వారా మనం కంప్లీట్ గా ఓవరాల్ నాలెడ్జ్ ట్రాన్స్మిషన్ అనేది జరుగుతుంది. సో ఇది జరగాలి అంటే we need to have an inference with the complete base of the knowledge base, so that we can have all the predictions like human beings. We are going to train the agents in such a way that they act like human beings. So that is the major goal of AI. So when we are going to take the knowledge base, so based on the knowledge base, we are drawing some sort of inferences, and based on these inferences, we are going to generate a system. So that is called as knowledge-based system or expert-based system. You will come across all these terms in the upcoming classes. So first one is the knowledge-based, another one is the inference system. So based on certain conditions, we are drawing some sort of inferences, and based on these set of inferences, we are going to generate the upcoming stages. So in this, mainly what we have is that we have some different kinds of knowledge. So first thing is that what you are going to perceive. So now I am going to say some aspects as far as AI is concerned. So how many concepts you are going to perceive in your mind, that depends. So that is the basic knowledge that you are going to have. And what sort of actions should be taken? If I want to know or learn this part of concept, what are the perseverances available in your mind at an instance of time? That tells the basic knowledge of yours. And what sort of actions to be taken in the later days so that I can learn in a better manner. So that suggests the basic inferences. So knowledge ni action ni inference ni రెండింటిని మ్యాప్ చేసేది నాలెడ్జ్ బేస్ సిస్టమ్. సో ఏంటి ఒకసారి హలో
No, sir, continue, please.
ఓకే
Continue, sir.
okay. So any questions you can ask in the middle, no problem. I'll just continue accordingly. Okay.
Till now, no questions.
Okay. So basically, I am trying to represent the overall knowledge. We have individual representation. So one representation is called as sentence. In the knowledge, we are going to have all the sentences. Based on the couple of sentences, we are drawing some sort of inference. Suppose sun rises in the east and sun sets in the west. So based on these two statements, I am going to judge the time period of the sun from morning to evening. So that is the inference I am going to draw based on the knowledge that I have. So I have two prepositions, and I'm going to add these two prepositions so that I can obtain a conclusion that what is the time period of the sun from morning to evening. So like that, I'm going to draw some sort of inferences based on the couple of sentences. Okay. So this is the major thing as far as knowledge representation is concerned. So now how we are going to draw all these kinds of knowledge level and basic levels of implementation. So first thing is that you are going to have the knowledge that what we are knowing, what you are knowing, these are the main things. The basic level or the abstract level, that is called as knowledge level. We are having logical level and we are having the implementation level. So implementation level, we are going to train the system with the help of a language called as Prolog. Prolog is the one of the language that is going to suggest the entire knowledge base of the particular language. So in the logical level, what we are trying to say is that what exactly is the system is going to know, and what exactly to be known, that is the logical level, to be known in future. So based on the conclusions, we are drawing some sort of inferences and we are drawing the conclusions accordingly. Suppose a taxi agent might know the Golden Bridge. He has known some aspects, and it has some sort of connections with the two states. So this is the general knowledge that is known to him. So we are drawing the logical level with the inferences. So what are the linkages between these three things? What is the linkage between Golden Bridge, and what is the link between San Francisco, and what is the link between Marin country? So these two are the two countries, and how he is going to link up all the statements in one set of statement that is called as preposition. So in this knowledge-based agents, we have two kinds of logic, knowledge-based. So one is prepositional logic, two kinds of logic. One is prepositional logic, another one is first order logic. So these two are the two important terms as far as knowledge representation is concerned. So mainly, I think you know, or you are aware of this particular problem is concerned. We have a Wimpus word problem. We have a Wimpus and we have some couple of pits that are available as far as Wimpus is concerned. So an agent should travel to that particular ultimate goal state, which is called as the last state. So should reach the final state by traversing all the states without going to Wimpus. సో ఏజెంట్ అనేవాడు కంప్లీట్ గా ఫైనల్ గా హీ నీడ్ టు రీచ్ టు దట్ పర్టికులర్ గోల్ స్టేట్ కి రీచ్ అవ్వాలి. ఇవన్నీ దాటుకుంటే గోల్ స్టేట్ కి రీచ్ అవ్వాలి. సో వెంపస్ కంట పడకూడదు, వెంపస్ కంట పడితే అది తినేస్తుంది. సో ద గేమ్ విల్ బి ఓవర్. సో వితౌట్ గోయింగ్ టు వెంపస్ హీ నీడ్ టు రీచ్ టు దట్ ఫైనల్ గోల్ స్టేట్. సో వెంపస్ ఉన్న చోట ఒక చిన్న పిట్ కూడా ఉంటుంది, పిట్ లో పడితే మళ్ళీ వాళ్ళు లేకూడదు. సో లైక్ స్నేక్స్ అండ్ ల్యాడర్ గేమ్, we have couple of snakes and we have couple of ladders. So the traveler should reach to the final goal state without going into the mouth of the snake. So the same logic will be occurred as far as Wimpus word problem is concerned. This is also one of the most important problem as far as AI is concerned. So what is the agent going to perceive regarding all the states? Where is the pit and where is the goal located? And how he is going to jump to that particular goal state without going to pits and without going to the Wimpus, and how he can recognize the Wimpus location. So there will be some sort of small smell coming up in that particular room is concerned where Wimpus is there. So based on that, he is going to recognize that there is some danger occurred over here, and he need to overcome the danger and he need to reach to that final goal state. So that is the major goal of the Wimpus word problem. So this is also one of the most important problem as far as AI is concerned. So how he need to go to that particular state, what are the couple of actions and what are the couple of plans that agent should do regarding the reachability of that particular goal state, how he need to climb, what are the actions to be taken. All these things are to be noted so that Wimpus will reach to that final goal state. So this is the yeah.
This Wimpus word problem is a first order logic or propositional logic?
No, it will not come under the logic aspects. Logic aspects we are coming forward.
Okay, then.
So they will ask in the exam like Wimpus word problem. Explain about the Wimpus word problem.
Yes, sir. Actually in the recent exam they have given explain the Wimpus word. Let me read the question.
Yeah.
Solve the Wimpus word either using propositional logic or first order logic. So they have given the information about the Wimpus word, like what will happen.
What will happen? What are the other aspects are concerned? So logic we need to draw and we need to go forward regarding the logic is concerned. So logic is nothing but how you are going to traverse.
The answer to the particular question.
Yeah.
The thing is, like what to write as answer for this particular question.
The basic thing is that
using.
I'm going to say that. So the basic thing is that you need to write all the basic steps as far as Wimpus word problem is concerned. As far as prepositional logic or first order logic is concerned, you need to represent all the sentences, right? All the actions in the form of logical aspects, logical aids. Like how you need to turn, here you are having a term called as turn 90 degrees. You need to represent this in the form of logic, first order logic. That is the main thing you need to do. Or prepositional logic that they have asked accordingly. You will come across that as well in our class. So there is the problem, but you need to track all the basic aspects of the problem, like how you are tracking with the chess game. Chess game is there, right? So there are certain problems that you may come across in the examinations in future aspects, as far as chess game or Wimpus word or other problems are concerned. You are going to represent the entire preposition with the help of actions, with the help of a logical representation that deals with the prepositional logic. Suppose turn right 90 degrees, you need to represent this in the form of prepositional logic. That is important, like how you are going to draw. right side by suggesting some 90 degrees or so. You need to suggest with some symbols. That's it. That is the major thing that happens as far as prepositional logic is concerned. And turn right and turn left. Suppose there are two terms. You need to join those two terms. Right side 90 degrees along with that, and you are joining left side 90 degrees. Like that, you need to write all the complete actions in the form of prepositional logic. That is the thing they have asked. Clear?
Yes.
Okay.
Yes, sir.
So each and every step you are going to
Yes.
represent with the help of prepositional logic. You will come across that in the next aspects. We are having next slides, so that we'll talk regarding that. So this is the agent, and the agent should reach to that final goal state. These are the couple of things that are represented as far as agents are concerned. And how the agent is going to reach to that final goal state by traversing all the steps. As I said, it should not go to the pit state. It should not go to the other state. You need to draw the inferences, right, regarding this particular aspect is concerned. This particular problem is concerned. Whatever might be the inferences
Yes.
that you are going to draw, based on the inferences, you are going to draw the final prepositional logic so that agent will reach to that final goal state. So these are a couple of steps. I think I'll share this material. You can go through the entire material so that you can understand each and every aspect. So as I said, logic is one of the major important concept as far as AI is concerned. So you are going to take note of all the sentences. Based on the sentences, you are going to represent all the complete aspects of that particular sentence in the form of symbolic representation that suggests the logical aids. So we have three types of logic. One is prepositional logic, another one is first order logic, another one is higher order logic. So mostly we are dealing with these two terms first. First one is prepositional logic, another one is first order logic. So I think you are aware of this particular term is concerned. As far as epistemology is concerned, it is one of the study which suggests only the basics of logic is concerned. So in the prepositional logic, we are only having some set of facts, and based on the facts, you are having the true or false constraints. And in first order logic, you are having some sort of basic sentences as far as objects and relationships are concerned. You are having objects and relationships in the first order logic. And based on that, you are going to derive with the next aspects. That suggests with the first order logic. You are having all the set of complete aspects of the sentence along with the objects and the facts. That suggests with the first order logic. But you are having only the couple of facts that have in the prepositional logic is concerned. Mostly in the examination, you might get a question like compare the prepositional logic with first order logic. How you are going to compare these two aspects? What are the aspects that differ from prepositional logic and first order logic? Like that, you might get some sort of questions. So as far as prepositional logic is concerned, I'm not going in depth of all the aspects because we are running out of time. We have only come out of time here. So mainly as far as prepositional logic is concerned, you are going to take some sentences, and based on the sentences, you are trying to add some sort of logical aids to that particular sentence, and you are representing the entire sentence in the form of a logical representation, logical aid or logical representation. You are drawing some sort of conclusions as far as two set of statements are concerned. So a statement, it may be true or it may be known or it may be unknown. Whatever it might be, you need to draw the conclusion with the help of the inferences that is available as far as first order logic, as far as prepositional logic is concerned. When compared to the first order logic, you are having all the sorts of differences as far as first order logic is concerned. You have all the set of objects along with the relationships. So mainly what are the basic things that you have in the prepositional logic is that you are having some sort of atomic sentences representation. That means all the sentences should be represented with the help of some literal values, and you are having true or false constraints. You are having all the aids of the logic. That means logical gates like and or not or whatever it might be. All the things that you are having. Along with that, you are having some sort of literals. You are going to represent the entire sentence with the help of all the literals. So if it is raining, if it is hot and humid, then it is raining. This is the sentence. I am going to represent this sentence like this. P and Q implements R. So this is the implementation as far as this sentence is concerned. Like that, you need to represent all the entire sentences with the help of the prepositional logic is concerned. So you are using only the basic logical gates and you are using the basic sentences so that you can represent the entire sentence in the form of the prepositional logic is concerned. There might be some couple of problems as far as prepositional logic is concerned. Like you will be given some sort of sentences. Suppose I like sweets. So I need to write a sentence like sweets. Who likes sweets? I. So I need to represent the entire things like this. Like sweets, comma, I. Like that, I need to represent the entire sentence. So you will come across sentences like this, and you need to construct all the prepositional logic-based sentences like this. So this is the main thing that happens as far as prepositional logic is concerned. You will have the syntax, syntax, and other aspects are concerned. And like this, you need to represent all the entire sentences. It's hot, it's humid, it's raining. Like that, you need to derive all the most of the sentences. So when we are having all the logic gates, we are having all the sort of elements that occur as far as your logic design is concerned. You are having tautology and you are having contradiction. Tautology means each and every interpretation should be true. No interpretation should be false. And contradiction, each and every sentence that you are derived from the base, so that will be false. And based on that, you are going to derive the other statements as concerned. So these truth tables, I think you are aware of all these things as far as truth tables are concerned. So like this, you are representing all the entire couple of sentences. So you are having some sort of theorems as far as prepositional logic is concerned. So one important theorem that you will come across in the examination is this modus ponens theorem. So you have a premise A, you have some implementation A turns to B, A implements B, and you need to conclude this particular statement is concerned, like how you are going to derive in the mathematics. So all the set of rules with the theorems that you need to prove as far as modus ponens theorem is concerned. Another one is unit resolution. This is also one of the most important aspects. You need to derive this particular theorem is concerned with the prepositional logic is concerned. You have a premise and you have a conclusion. You need to derive from the premise the conclusion statement accordingly. That is the major thing that happens as far as prepositional logic is concerned. So this is the way how you are going to derive the modus ponens theorem with the help of the truth table is concerned. Both are true, it is true. Both are false, it is false. So based on the and or implementation strategy, you are coming across all the couple of statements, and based on that, you are trying to prove the particular rules are concerned. Another most important thing is that inference is concerned. So mainly, we are trying to derive some sort of conclusions with the help of the set of rules called as inference. So now we are deriving some sort of inferences. How can we say that our inference is right? We are going to judge that today weather will be around 40 degrees. How you are going to judge it with the help of two statements? Like yesterday it is 35 degrees, today it is 40 degrees, tomorrow it might be 45 degrees. How you are going to judge it? And how valid is your statement is concerned? That is the inference. How valid your inference is concerned. So that is the main thing that happens as far as the resolution rule is concerned. So you need to have the validity as far as inference is concerned. How you are going to derive that this inference is correct? How you are going to judge it? That is the main thing as far as resolution is concerned. So in the resolution, yeah. Hello. Okay. Hello.
Yes, sir.
Okay.
Hello.
So how you
Sir,
are going
am
to
I
derive?
audible?
Yeah, you are audible. So how you are going to derive the basic aspects as far as inference is concerned? How valid is your inference based on the set of rules that you need to prove with the help of a theorem? So this is the theorem. You are having some set of tautologies, and based on the tautologies, you are going to derive some conjunctive normal forms. We are having disjunctive normal forms. We are having conjunctive normal forms as far as our learning is concerned. So you are going to derive the conjunctive normal form based on some set of statements, sentences, which is valid. So you are going to have only the true statements. So true statements with the help of conjunction, that means and get. So based on that, you are going to derive that which statement is true, which statement is false. You are going to check the validity of the statement. That's it. That is the main concept of resolution is concerned. So this is also one of the derivation as far as the resolution inference rule is concerned. You are going to derive only the basic aspects of the logic is concerned. And this is the basic proof as far as weather problem I have said, right? So we are having premise. So it is humid. I have written like this, HU. If it is humid, it is hot. I am trying to write this like this, HU turns to HO. So mod exponents, it is hot. I am trying to prove that it is hot. HO. I am going to derive this. So HO and HU turns to R. If it is hot and humid, it is raining. So these things, it comes only through practice, mainly only through practice. So these are the sentences you need to practice further so that you can understand all the aspects of the basic sentences. So in the examination point of view, you will get some questions as far as mode exponents and resolution theorem is concerned. So you need to prove the resolution theorem either by contradiction or by tautology, whatever it might be. You need to do the validity of that particular statement is concerned. Okay, so I think we are running out of time. We are having 10 more minutes. Okay. So based on the resolution rules, you are having all the set of classes. You are going to set some sort of rules that are called as on class and horn class rules. Okay, this is also one of the major logical concept as far as this aspect is concerned. So it comes under the first order logic. You will come across the first order logic. These are all regarding the prepositional logic aspects. And so as I said, this is the major sentence. You have two sentences, and based on the two sentences, you are going to derive the third sentence. So see, this is the representation of the Wimperswald problem with the help of prepositional logic. Right? You have written all the steps in the form of set of rules. So this is the thing that you have done as far as Wimperswald problem is concerned. Entire thing you are going to derive with the help of prepositions, and based on the prepositions, you are reaching to that final goal state. Which states are visited, which states are not visited, which states are available in the set. Like that, you are going to derive to that final conclusion state. Based on the couple of rules and couple of basic logic aids, like as I said, it may be mode exponents or it may be resolution, whatever it might be. Based on that, you are going to derive to that final conclusion is concerned. So you need to represent the entire thing with the help of Wimperswald. So you need to write each and every action, right? Based on that actions only, you can draw the prepositions accordingly. So these prepositions are drawn based on the actions that are performed in the Wimperswald problem. This is the third move, and you are proving all the entire steps with the help of the proof. This is the entire proof. So this is also one of the Hunter problem. You are having some sort of things like Hunter problems and other aspects as far as prepositional logic is concerned. Coming to first order logic, as I said before, you are having some sort of sentences. Based on the sentences, you need to represent father of Mary is equal to John. Like this, you are going to represent the entire sentences. So in the examination point of view, you will have come across the sentences like this. So he likes sweets, he do not like sweets. You need to represent each and everything with the help of the first order logic, with the help of the entire representation of all the elements. So we have two kinds of quantifiers. You have universal quantifier and you have existential quantifier. So universal quantifier, I think you are aware of the, if you are aware of the basic reasoning aspects, you will come across all the quantifier elements. Like universal quantifier and existential quantifier. Universal quantifier exists for all the elements, but there exist only some of the elements that dissolves with the existential quantifier. And you need to draw all the rules like this. You will have some couple of sentences, and you need to represent all the sentences with the help of the first order logic in this manner, in this particular manner. Each and every sentence should be represented with the help of the logical notation is concerned. So likes the sun. So I have represented the sun with the help of the value called as x. every Gardner likes the sun. So Gardner, which is going to implement like the sun. Like this, you need to represent the entire sentence with the help of the first order logic is concerned. In the examination point of view, you will come across some of the questions as far as first order logic is concerned. In this, you do not have any sort of theorems. So this is also the logical representation of the Wimpus-Wald problem. You will come across the Wimpus-Wald problem and other basic problems as far as the logic aspects are concerned. So you need to practice all these things as far as logic is concerned. Okay. So one more thing left, that
Yes,
is
sir.
the quantifier. We are having one more aspect, that is the, I think we are left with the particular term called as